Hi, my name is Steve Lozier. I'm an education specialist in the Metropolitan School District of Wayne Township, and I'm focused on the planning and implementation of project-based learning units in our schools. This module is one of many designed to help teachers better understand project-based learning and design and develop PBL units to engage and challenge their students. This presentation is available to you by following the link in the My Big Campus bundle as well as the Google folder associated with it. And I'd suggest that you open this presentation in another tab, as you may want to pause this video and click on a link or resource in that presentation to explore further. Please note that if you're new to PBL and you're building your knowledge, this video would be considered the second in the sequence. So, we're going to talk about the degrees of inquiry. So project-based learning can be placed on a continuum of inquiry. The movement of instruction along this continuum shifts largely due to relevance, and the more relevant the content is made, the more closely that instruction gets to project-based learning. However, it may be important to note we also see an increase in rigor and student-centered instruction as we move towards project-based learning. So if you're familiar with Bill Daggett's work with rigor relevance framework, or the Quad D framework that is supported by his theories, this would make sense there. An understanding of the differences in these degrees is useful for educators in considering which form of inquiry aligns best with their educational philosophy or style, as well as considering how they could change their approach to increase the inquiry. Ultimately, each degree can be useful to increase student engagement, and thinking should be carefully considered when to leverage that for learning. And so maybe it's my recent work with the mathematical practices, but I've been thinking in math a lot more lately, so I'm going to use kind of an equation of inquiry to explain this, and we'll move through that in these next slides. So if I wrote this as kind of an equation here, I want you to think of it in terms of content and skills that we teach. And remember, we talked in the previous module about 21st century skills as also being part of that. If we increase that content and skills by the relevance power, we get increased rigor through engagement. So then I'm going to explore that relevance piece in the next few slides. So, looking at the equation at the title at the top, content and skills to the question or the inquiry power. So, inquiry is innate, right? We're born with inquiry. We're born with these questioning kind of nature to who we are as humans. And people can make their entire careers out of exploring one single question, and they may never even get that question answered, but that's just the nature of us. And then also remember, units, big ideas, essential questions, and enduring understanding, units are built out of those questions. So education is rooted in inquiry and questioning, right? Socrates and Plato proved this centuries ago, and that's why I use that image here. We see evidence of it in our curriculum and in our classroom. But David Sousa says that the brain that does the thinking does the learning. So, well, we as teachers do all the thinking and planning the unit, and then try to take students down the same path of thought, hoping the engagement we designed at the beginning will carry them through. And this often results in a fragmentation of the planned, the taught, and the learned curriculum, where once students enter the equation, we struggle for them to construct learning in the way we've planned or designed it. Highly effective teachers recognize this and make adjustments in the taught instruction while keeping the same learning targets as indicated by assessments. Teachers may be highly skilled at planning but struggle to execute or implement those. Recognizing students are not performing where they thought, they may make instructional adjustments, but they also risk shifting the rigor by changing learning targets while trying to, quote, cover the content. In this process, teachers can take over the thinking for efficiency's sake and dominate the instruction. So Hattie's research points out that next to the teacher talk, questioning is the second most dominant classroom practice. This teacher dominance results in an illusion of learning where students never construct the essential concepts or understanding necessary for transfer, but they may perform well on certain lower level assessments or on the surface. So in the long term, this results in students not being able to connect their knowledge or skills to the next unit or teacher next year, so accusing other teachers of never teaching that skill or concept. It's not that teachers didn't teach it, it's just that students didn't learn it. So, PBL uses a question or inquiry model at that base level, and so it builds upon that by leveraging the engagement of questioning, by asking students to transfer the content and skills taught in class every day and connect it to the engagement and relevance of the driving question or challenge and the task and the product at hand. So instead of teachers asking the questions, students are asking them. And to illustrate that, I want you to think of it in terms of every lesson, the student-centered lesson that you use in this process transfers back to that driving question or challenge. So it answers the question, why do we need to know this? Well, we need to know this because we identified it as a need to know. I've created this instruction to meet that need to know, and it's helping us move closer to the answer or the solution to the problem. So, taking it to the next level, content and skills to the project level. So, BIE is an organization that I've referenced in all these modules, and they worked with us early on in our understanding of PBL. They use a metaphor of a meal. So they distinguish between PBL and projects, saying that we offer up projects as dessert of the learning instead of making the inquiry and student-centered nature of PBL the main course of instruction. So when students ask, why do we need to know this, either directly or indirectly, and I would remind you, I think students are always asking, why do we need to know this? In a project, we kind of tease them, saying, so we can do this fun, engaging project in a week or two. Just stick with me through these 2 weeks, and then we'll do it. So in the learning moment, students are left waiting. We know some students will passively comply and fight through the liver and onions to get to the ice cream, while others will outright rebel and refuse eating and still wait us out. Either way, we lack the authentic engagement necessary for true learning in that context. So, how does a PBL use a project? PBL leverages that engagement piece of a project by asking students to create a performance-based product. And it's also often similar to project implementation in that it utilizes groups, but PBL is much more intentional and purposeful in creating and utilizing those groups, which we'll look at. So here's a way to think of it. Ask yourself, when is transfer in a project? So if we go back to what I said about David Sousa, if the brain that does the thinking does the learning, who is doing most of the learning and when are they doing it? It's the teacher as they're moving the class, the individual students, kind of through this instructional cycle. So they're going to use these elements here, and then they're going to put the project as the dessert at the end. So now let's get to the problem-based level, or the P-RBL is how that's sometimes designated in project-based learning conversations. So this is a form of inquiry-based instruction that challenges students with several smaller problem scenarios rather than a single large project-based learning unit. It often includes the elements of PBL like an entry event, a need to know process, and student-centered scaffolding, and it may or may not teach or assess 21st century skills. We see these a lot in the math content areas as the need for content coverage causes teachers to create smaller problem-based scenarios that aren't as extensive in terms of time as a problem or a project-based learning unit. I also want to point out that there's challenge-based learning, which I think is copyrighted by Apple. So point that out here because it's an engaging multidisciplinary approach to teaching and learning that encourages learners to leverage the technology they use in their daily lives to solve real-world problems. Challenge-based learning is collaborative and hands-on, asking students to work with peers, teachers, and experts in their communities and around the world to ask good questions, develop deep subject area knowledge, identify and solve challenges, take action, and share their experience. So we see how Apple's kind of leveraged the technology piece here. They acknowledge those other stakeholders in the process, but technology is kind of a big driver of the learning here. That's no surprise. They make lots of money off of that. So that's just a little bit of a tweak, but I point that out because Apple does have some decent resources out there to look at. So they also want to sell you computers, though. Just head up. So let's get to the project-based, the PBL, when we think about that equation, content and skills to the project-based power. Learning is contextual, creative, and shared. Students collaborate on meaningful projects that require critical thinking, creativity, and communication in order for them to answer challenging questions or solve complex problems. By making learning relevant, students see a purpose for mastering state-required skills and content concepts. Students aren't just assessed on their understanding of academic content, but also on their ability to successfully apply that content when solving authentic problems. And then through this process, project-based learning gives students the opportunity to develop the real-life skills required for success in today's world. Those are those 21st century skills, those soft skills as sometimes they're called. So in the previous module, I hinted at Schmoker, but here's his kind of quote. So to illustrate the risk of poorly implemented, content light, unfocused, fluffy PBL, I use this quote. So this is engagement-heavy PBL and presents itself more as a technology-infused project rather than the kind of PBL we encourage and support. So pay particular attention to Schmoker's emphasis on coherent curriculum and effective lessons. Schmoker states this nicely in the quote on the next slide from Focus as well. This comes from his book Focus. So I'm going to give you a chance to pause here and read that quote. And then this is his warning. I'll give you a chance to kind of read through that. So it's our work with Schmoker that really caused us to embed the focus on rigor and the use of best practices in our definition of PBL to ensure that those things are present when we're using PBL or when we're not. So to illustrate this, again with that kind of visual, project-based learning done badly looks like this. Maybe you design something really cool to launch, you tell kids what they're going to do at the end, and then you let them go. It's a disaster. This is project-based learning, and just to show you the shift from the unit we looked at before in terms of a project, we're asking again, when is the transfer? So the transfer here is throughout the learning. It's every day. It's with every instructional moment. And then I've also added to this slide some of the facilitator duties. So a way to think about that is a transition from being a teacher to being a facilitator. So as a facilitator, you check those milestones. You revisit the no need to know chart and you think from it and you help the students think from it. You develop mini lessons or workshops with checks for understanding to meet those need to knows. You do individual or group interventions as kids kind of chart their own path toward the goal at the end in their own product and presentation. You refocus and dissipate stress and anxiety, and you ultimately respond to student needs. So you can see here how some of the same elements we used in a project or throughout that linear progression of learning are now used in the context of a PBL. And I'll also point out, no student has ever learned in a linear way, even though we often plan that way. Their path to that learning is varied and has a large number of variables. So just to refocus back on the content and skills to the relevance power, think about it in terms of inquiry or questions. Think about it in terms of using a product. Think about it in terms of problem-based or scenario-based learning. Challenge-based learning fits there as well. And then there's project-based learning, which is really that higher level there. So we're going to take a moment and look at an example provided by BIE and created by Common Craft here. It's about 4 minutes long, and then we're going to connect it to the learning of this module. This is where you're going to need to open this presentation. Or actually, I'll just play it for you. I think. No, actually go out, open this presentation, and click on the slide to see that. So as I hope you've seen in the video, is this teacher, Mr. Simmons, has taken microorganisms and taken them to the relevance power. And so we're going to explore the sources of that relevance. So he engages his students with a problem, which is the flu. He puts it in the context of a driving question: how can we educate elementary school students about how viruses spread? He puts it in terms of a public product or presentation with student voice and choice at the end. And you can see that with the choices they have and how they present. And they're going to present it to elementary school students. I needed to know content, so to use and apply it. Partnerships and audience are those elementary students. Teaching and assessing a 21st century skills, they point out the critical thinking, collaboration, and communication, and then you see the authentic assessment piece a little bit in terms of that presentation. So if we're going to put the degrees of inquiry over this kind of example, if Mr. Simmons was going to ask a question, he would ask, what causes us to get sick? How do we get the flu? Why do germs make us sick? If he was going to use it as a project, he would say, after learning about microorganisms, pick an illness and study how that microorganism infects and causes sickness. If this was a problem-based scenario, what happens if one of us gets the flu? Why did Billy get us all sick? And then the challenge, example, but with technology driving the larger degree of instruction. So you would use that problem-based kind of approach with a challenge. And then finally, project-based. How could this PBL increase rigor or relevance? So they could partner further with doctors or scientists. They could have to create a product that was like a medical brief or a journal article. They could create a website. So you could see how we could increase the rigor and relevance in this example. And on the continuum, the example in the video is just kind of a run-of-the-mill project-based learning unit. I point out too, using any of these forms of inquiry has a purpose and a place in a curriculum, and you need to make those decisions based on your curriculum and the needs of your students, whether you use just a question or whether you use project-based learning. And this kind of just shows, just to connect one of the PBL components here, remember that the most common inquiry structure used in PBL units is the know, need to know. This is often a teaching chart or a digital space T-chart. And many teachers connect this idea to what they already know using a KWL, so a know, a want to know, and a learned. These are very similar, except that the know, need to know space is a living space for inquiry where, as learning progresses, need to knows become knows, and new need to knows are constructed. This space drives the learning of the unit, and there are other inquiry structures, but this has become kind of the industry standard when it comes to PBLs. As students get more familiar with the inquiry structure, they will adopt the know, need to know, even outside of a guided PBL experience, and use it as a critical thinking structure of any learning task. So here's a hypothetical example connecting the video you just watched. Notice how the teacher would need to act as a facilitator or bridge for students to connect their need to knows to a specific standards based content and skills. So later in the planning process, after you've got a working draft of your project idea and driving question or challenges, boxes J and K are placed to think through what you would speculate your students' need to knows will be for planning purposes. So please know, when students have voice and choice, there will always be ones that you did not think of or consider, as well as content and skills you as the facilitator will need to guide students to consider or think about. So this concludes our exercise in examining PBL and the degrees of inquiry. If you are following these modules in sequence, the next one is generating a PBL unit idea. In this module, you will think of a relevant and engaging unit idea that comes from either your content standards or the community or world your students are engaged with. If you start with standards, you root those in an authentic context. And if you start with a community or worldly problem or challenge, you build your content standards into the inquiry of the unit. Thank you for your time.